Alright, we can now move on to section 3.7, which is derivatives of inverse functions. And we're starting this out with a theorem. We're going to say let f of x be a function with an inverse y equals f inverse of x. Now, if I wanted to take the derivative of the inverse, all I do is the derivative of that is going to be 1 over the derivative of f at the inverse. So the way we are going to use this in this class is going to be finding the derivatives of inverse trig. Derivatives of inverse trig functions. We're going to do this kind of like how we did it whenever we talked about the derivatives of just trig stuff. I'm going to work out what the sine is, and then everything else just follows from that, okay? So let's find the derivative of inverse sine of x. So I'm going to do this using this rule I wrote down here, okay? So it's going to be 1 over the derivative of the sine, which we already know is cosine, at the inverse. So at inverse sine of x. So to figure out what this is, I need to know what the cosine of inverse sine of x is, okay? So let's look at that. Let's draw a triangle. Inverse sine of x means that I know if I let this be equal to theta, I know the sine of that would be x over a 1, right? X over 1. And I know sine is opposite over hypotenuse. So I know from this part right here, I have an x right there and a 1 right there. Using the Pythagorean theorem, I know this third side over here would be equal to my hypotenuse squared. 1 squared is just 1, minus this 1 squared, so minus x squared. So to find the cosine of that, I know cosine is equal to adjacent over hypotenuse. So square root of 1 minus x squared over a 1. So what this means I get is 1 over, because of this 1 over. And from the cosine, I know I get square root of 1 minus x squared. So the derivative of inverse sine of x is equal to 1 over the square root of 1 minus x squared. Using this same thought process, I can find the derivatives of every other inverse trig. So if we did this, so we already know we did inverse sine. The derivative of inverse sine, we just said, was 1 over the square root of 1 minus x squared. If I did that same process to inverse cosine, I would get negative 1 over the square root of 1 minus x squared. If I did the same thing to tangent and did the derivative of inverse tangent, I would get 1 over 1 plus x squared. If I did the same thing to cosecant, the derivative of inverse cosecant of x is negative 1 over the absolute value of x times the square root of x squared minus 1. Let me rewrite that so that's clearer. If I did it to secant, the derivative of inverse secant of x is equal to positive 1 over the absolute value of x times the square root of x squared minus 1. And then cotangent, the derivative of inverse cotangent of x is equal to negative 1 over 1 plus x squared. Just like when we wrote all of these down for just the plain trig stuff in section 3.5, Notice how the cos over here, cosine, is the same as what the original was, just changing what the sine is, right? So like sine is equal to this, cosine is the same thing with just my sign changed. Same thing over here, secant is this guy, cosecant is the same thing with my sign changed. And then the same thing here, tangent, I get that, cotangent is the same thing, but with my sign changed. So that might be a helpful way to remember these. All right, so let's use these formulas to find some derivatives. Example. Let's find the derivative of inverse cosine of 3x minus 1. All right, so from this, the first thing I see is that I'm going to need the chain rule because I have something else inside of this bigger part, right? I have inverse cosine of some stuff, right? So because of that, I'm going to need the chain rule, okay? Remember, by the chain rule, I do the outermost part to start with, right? So the outermost part is the inverse cosine. So then I want to do the derivative of that to start with. Derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. So I'm using that. So that's going to be negative 1 over the square root of 1 minus. Now, inside of here, I have 3x minus a 1. So that's what I'm going to square. So 3x minus 1 squared. But then by the chain rule, I have to multiply that by the derivative of the inside stuff. So multiply that by the derivative of 3x minus 1, which we know is 3. So that's what I get. Inverse cosine of 3x minus 1. The derivative of that is negative 1 over the square root of 1 minus the quantity 3x minus 1 squared times 3. If you wanted to, you could simplify this to be negative 3 over square root of 1 minus, and then you could square this out if you wanted to. It doesn't really matter though, so I am fine if you just stop with this, and that's okay. Let's do another example. Let's do the derivative of inverse tangent of x squared. Inverse tangent of x squared. So the same thing here, I have the inverse tangent of some stuff, and so I start with the outermost part. The derivative of inverse tangent I know is 1 over 1 plus x squared. So I'm going to use that. Like we said, 1 over 1 plus. Inside of here I have x squared. So it's x squared squared. But then now I have to multiply that by the derivative of the inside stuff. The derivative of x squared is 2x. So you can just stop right there. Or if you wanted to, you could simplify that to be 2x over 1 plus x squared squared is x to the 4th. Let's do some more examples. Let's find the derivative of x squared inverse sine of x. So for here, if I look, this is a product because it's x squared times inverse sine. So I need the product rule, okay? So I'm going to start by, we take the derivative of the first part. The derivative of x squared is 2x. Leave that part, inverse sine of x, plus leave the first part, so x squared just stays x squared, but the derivative of inverse sine of x, we have already said, was 1 over the square root of 1 minus x squared. So, times 1 over the square root of 1 minus x squared. And that is it. So these really aren't too bad once you know what the rules are. One more example. Find the equation of the tangent line, or I'll say it, find the equation of the line tangent to the function f of x equals inverse sine of x at x equal to 0. So we've actually done a lot of these, right? What I need is I need a point and I need a slope. A point isn't hard because I just plug in what the value is for x. So plug in f of 0, which is inverse sine of 0, which means I need to know where is sine equal to 0. If I look at the unit circle, sine is equal to 0 right here. So that's going to be equal to 0. So the point I have there is just the point 0, 0. Now to find my slope, remember we have to find the derivative. We already know that the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. So my slope is the derivative at that point. F of 0. That's going to be 1 over the square root of 1 minus 0 squared. That's going to be 1 over square root. 0 squared is 0. 1 minus that is just 1. Square root of 1 is 1. 1 over 1 is 1. So my slope is equal to 1. So now that I have a point and I have my slope, I can put this into point-slope form. So y minus 0, because y minus the y that I know is equal to my slope, which is just 1, times x minus the x, which simplifies down really nicely because the only thing I have over here is a y, and the only thing I have over here is 1x. So y equals